Hi everyone, in this video we're going to go through 6E, solution of trig equations. So not really too much theory here because we're just solving equations, but I have put in the exact values again, just so I don't have to keep scrolling up and down, and I'm just not familiar enough with them at the moment because it's been a while since I've done trig equations to remember them off by heart. So I think it's probably just best to have here so we can refer back to them. I would strongly encourage you to put a copy of these somewhere where you often look. So maybe on the shower, your shower screen, back of your toilet door, or somewhere in your bedroom, maybe on your laptop, just somewhere where you can remember these exact values because you're expected to remember them. So you either remember this table or remember the triangles, like I said back in, I think it was the 6A or 6B. Anyway, let's move on. So question 1, we've got to solve the following, and we've got a given domain, okay, so from 0 to 4 pi. So I'll talk about the domain in a second. So we always got to think about the exact value. So previously we were given the value of x, and we had to find, sine pi on 6 or sine pi on 2, sine pi. Now we've got the solution, so we have to figure out what x is equal to. Now you can do this on your calculator. All right, so if we were doing it on the calculator, just make sure you're in radian mode and just go to trig. So for the first one, I think it was sine. So inverse sine of 1 on root 2. Now remember, 1 on root 2 is the same as 2 on root 2. Just a bit annoying that they're writing it 1 on root 2, but 1 on root 2 is the same as 2 on root 2, and the solution is pi on 4. Okay, but we're going to do it all by hand. Okay, I think all the questions I've chosen are ones to do by hand. Okay, so the first one, let me just get my pen ready. Okay, so let's write it over here. So sine x equals 1 on root 2. So x is equal to inverse sine of 1 on root 2. So x is equal to pi on 4. So we just did that on the calculator, but you can also see from this table. So remember, 1 on root 2 is the same as root 2 on 2. Okay, so just rationalize the denominator there. So your first solution is pi on 4. Now, because we've got this domain, okay, we're going to have more than just one solution. Now, you can graph it and think about what it looks like graphically, but I think the easiest way is to use the unit circle. So let's draw the unit circle. All right, so we're going from 0, pi on 2, pi, 3 pi on 2, and then back up to 2 pi. Now we're actually going all the way to 4 pi, so we're going around the circle twice. All right, so our first solution is here, pi on 4. Okay, so that's your x. Now, it is positive. All right, so we wanted positive 1 over root 2. So we're only looking at quadrants where sign is positive. So remember, we've got A, S, T, C. So all are positive, only sine is positive, tan is positive, and cos is positive. So our second quadrant is going to be our next solution here, because that's where sine is positive. So that solution is pi minus pi on 4. All right, and then we go around the circle again. So our next solution is going to be 2 pi. That looks like an 8, but it's 2. I might write that again. Okay, so 2 pi plus pi on 4. And then we're at 3 pi minus pi on 4. Okay, so we have 4 solutions. So we can't leave it like that. We do need to simplify. So our solution is x equals pi on 4. Okay, we don't need to simplify that. Pi minus pi on 4 is 3 pi on 4. Two pi plus pi on 4. So if you think of 2 pi as a improper fraction with a denominator of 4, it would be 8 pi on 4. So 8 pi plus pi is 9 pi. So 9 pi on 4. 3 pi minus pi on 4. Again, if you think of 3 pi as an improper fraction, so that would be 12 pi on 4. So 12 pi minus pi is 11 pi on 4. So we have those 4 solutions. All right, I just noticed I was working on the wrong document. So all the working out is gone. So I was working on the normal notes, and I actually have another file for the completed notes. So yeah, that's why everything's just disappeared. All right, let's do 1b. At least we've now got space to do 1b over here. So we've got cos x equals root 3 on 2. Okay, so we look at our exact values. So that means x is equal to, now we've got to find cos root 3 on 2 is pi on 6. Now we're only dealing with positive, so when we're working with our unit circle, so the same as before, we're going from, not pi, 0, pi on 2, pi, 3 pi on 2, and 2 pi. And then we're going around the circle again. So our first solution is in the first quadrant, x, so cos is positive there, and so all s, t, c, so all sine, tan, cos. So cos isn't positive again until the 4th quadrant. So remember, we always go from the x-axis, so that solution is going to be 2 pi minus pi on 6. Now, we've got to go around the circle again. So we've only gone around from 0 to 2 pi, so we've got to go around again. So the next one is going to be 2 pi plus pi on 6. And then the next solution is 4 pi minus pi on 6. All right, so let's write them all out. So pi on 6, we don't need to simplify. 2 pi, I can rewrite as 12 pi on 6. So 12 minus pi is 11 pi on 6. And then we've got 12 pi plus pi is 13 pi on 6. And then 4 pi is 24 on 6, so 23 pi on 6. All right, let's move on to question 2. So question 2 is slightly different because they're now negative. Okay, so we still start off with, I might just do 2a here, sine x equals negative half. So we still look for where it's a half. All right, so sine is a half at pi on 6. And because we want it to be negative, it does have to be a negative, not necessarily negative pi on 6. Okay, and I'll show you in a second. I probably should write that a little bit differently. Sorry, let me just I'm just going to rewrite this because technically what I've written is not mathematically sound. Okay, so sine pi on 6. Is it pi on 6? Oh, I'm losing my marbles. Pi on 6 equals a half. All right, but we want it to be negative a half. So remember, we've got to figure out where sine is negative. So 0, pi on 2, pi, 3 pi on 2, and 2 pi. This time we're only going from negative pi to pi. So this point here, if I was going 0, would also be negative pi. Okay, so we're negative for sine in the 3rd and the 4th quadrant, okay, where tan and cos are positive. So our first solution is going to be negative pi, because remember our domain is here. So negative pi plus, so we're here, plus pi on 6. Then our next solution is here. So 0 minus pi on 6. Then our next solution, got to go right around again, and then we're at pi. Okay, so we only have 2 solutions here. So you got to think, well, we're going from negative pi to pi. Previously, we were going from 0 to 4 pi. So we had more solutions because we were going around the circle twice. Here we're effectively only doing one full rotation. We're going from negative pi all the way back to pi. So the only 2 solutions we have are negative pi plus pi on 6, which if you wanted to write negative pi as an improper fraction, it would be negative 6 pi on 6. So it's going to be negative 5 pi on 6. And then negative pi on 6. All right, so they're your 2 solutions. All right, let's move on to question B, if we can find a little bit of room to do it. Let's do it over here. 2b, cos x equals root 3 on 2. So this isn't negative, but remember our domain. So we're going from negative pi to pi. So x is equal to, let's just go back to our exact values. So pi on 6. And we've got to find solutions between negative pi and pi. All right, so just scroll down a bit. Our first solution, because we want cos to be positive, is going to be, actually we've got to start at negative pi. Sorry. So we want it to be positive. So cos is actually negative in the 3rd quadrant, so our first solution is going to be here. So 0, should just write it here, 0 minus pi on 6. And then our next solution is going to be here, which is pi on 6, which I've already got, but I'll write it again. And then we're at pi. So our 2 solutions are going to be x equals negative pi on 6 and pi on 6. All right, I'm going to change color so we can differentiate between our 3 questions. So let's do 2c over here. So we've got cos x equals negative root 3 on 2. So I know that pi on 6 is my general solution, but I want it to be negative. Okay, so we've got to say, well, where is cos negative? So cos is negative here and here in the 2nd and the 3rd quadrant. So our first solution, if we're starting, remember, going from negative pi to pi, we're starting at negative pi. Our first solution is going to be negative pi plus pi on 6. Then we're in the 4th quadrant, cos is positive. 1st quadrant, cos is positive. So our next solution is going to be in the 2nd quadrant, and that is going to be pi minus pi on 6. All right, so if I just tidy that up, so negative pi plus pi on 6 is negative 5 pi on 6. And pi minus pi on 6 is 5 pi on 6. All right, I must confess, I do find these enjoyable to do, but they can be quite challenging at first. So we've got a lot of questions to do for, I think, the 6E. So do them all, and do some more questions in the textbook if you want some more practice. There are questions in your textbook that relate just to the calculator, but the calculator is easy stuff. This is the hard stuff, actually doing it by hand. All right, so question 3. I'm not going to do every single one because I want to get to some harder questions. So let's do A. So we've got root 2 sine x minus 1 equals 0. Oh, not 1 equals 0. All right, so all we got to do is get x by itself. So I could probably do this in more than one go. All right, I'm going to put that 1 over and then divide both sides by root 2. So 1 over root 2. Okay, so we don't want to square it to get rid of that square root sign, okay, because we just want to get x by itself. So keep it as root 2. So x is equal to, so let's go back up here. I know it's going to be pi on 2. Sorry, not pi on 2, pi on 4. Listen to me, I was so confident. I knew it was pi on 4. I don't know why I said pi on 2. Pi on 4. So that, let's just check our domain. So from 0 to 2 pi, let me draw the unit circle over here. So A, S, T, C. So we're looking for solutions. Let me just write the values in. All right, so we're looking for solutions in the first quadrant. So we've already got that, pi on 4. And the next time sign is positive is in your second quadrant. So that's going to be pi minus pi on 4. So that's going to be pi on 4. And 4 pi on 4 minus pi on 4 is 3 pi on 4. All right, so you're just basically rearranging your equation. All right, let's do another one. I'm going to do E. 1 minus root 2 cos x equals 0. Okay, so this time we're going to have cos x equals, so that 1 is going to come over as negative 1, and then we're going to divide by negative root 2. All right, so just be careful with that. So negative root 2. So we're going to end up with 1 over root 2. So that gives us x is equal to pi on 4. All right, so in your first quadrant, cos is positive, so we've already got that solution. And then in the fourth quadrant, so we're going to go 2 pi minus pi on 4. All right, so pi on 4, 8 pi on 4 minus pi on 4 is 7 pi on 4. All right, so they're your two solutions. All right, let's do F just to finish it off. Whoops, don't want that. I'll do F in red. 4 cos x plus, 2 equals 0. So we've got 4 cos x equals negative 2. So cos x equals negative a half. All right, once we bring that 4 over. All right, so let's have a look at our exact values. So cos half is at pi on 3. All right, so pi on 3 is what we want, and we want it to be negative. All right, so let's have a look at our solutions. All right, so the first time cos is negative is in the second quadrant. So it's going to be pi minus pi on 3. And then it's also negative in the third quadrant. So it's going to be pi plus pi on 3. Okay, so 3 pi on 3 minus pi, so 2 pi on 3. And then 4 pi on 3 is your other solution. All right, let's scroll down. It is, just while we're doing this, absolutely freezing today. It is 2 degrees while I'm doing this video, and my hands are so cold. But also, as some of you know, I'll be in Cairns later today, which I'm very excited about. So I can put up with the 2 degrees, knowing I'll be in 26 degrees later today. All right. Now, if you can have a look at question 7, you will notice that instead of having just theta or x by itself, we now have a coefficient. Okay, so we know that relates to the period, but it doesn't, the only thing it changes really is your domain. All right, so the 2 is just changing your domain. So we're going from 0 to 2 pi. Now, whatever your coefficient of theta is, or x, we multiply our domain by. So we're going to multiply this by 2 and multiply this by 2. So instead of going from 0 to 2 pi, our solution, our domain doesn't change, okay, but when we're finding our solutions, we're going from 0 to 4 pi. Okay, so we can find all our solutions. Okay, so question A, let's do that here. So it's not question 1, it's question 7. 7a, we've got sine 2 theta equals -1/2. All right, so we just want to know, don't worry about the 2, because the 2 is just changing our period, okay? We just need to focus on, well, what value of theta gives us -1/2. So if we had sine theta equals -1/2, theta is equal to, let's go up, was a half? Pi on 6. All right, what I should have done here is positive. Okay, so pi on 6. So with our unit circle, we're going from 0 all the way around. I really should have one of these drawn. Okay, and then we go around again. You can write in the values if you like, but we know we're only going from pi, and then we're going to from 3 pi and then 4 pi. So we don't really need the pi on 2 and the 3 pi on 2 there, because we always go from the horizontal. All right, I'm going to change colors just because I'm not really feeling this blue. Okay, so we want sine to be negative, okay? So we're looking for, let's just put these in. All right, the third quadrant and the fourth quadrant. So our first solution is going to be pi plus pi on 6. Okay, so that's the first time from 0 to 4 pi that sine is negative. The next time it's negative is in this fourth quadrant, so it's going to be 2 pi minus pi on 6. Then we go around again, okay, because that's because of the 2 theta. All right, so then we've got 3 pi plus pi on 6, and then lastly 4 pi minus pi on 6. All right, so let's just tidy it up. So we're going to have 7 pi on 6, 11 pi on 6, what's that, 19 pi on 6, and then 23 pi on 6. All right, I actually just realized I've forgotten one important thing. We're not finding just theta, we're finding 2 theta. All right, so 2 theta is equal to this. So what we need to do is now get theta on its own. So we're dividing everything by 2. Now, I'll just show you quickly an easy strategy, because all you're doing is changing your denominator. So if I had 7 pi on 6, and we want theta on its own, so we're dividing by 2. Okay, and that's the same as, terrible 7, multiplying by 1/2. So effectively, all we're doing with our 6's on our denominators is making them 6 times 2, which is 12. Now, the reason I knew I made a mistake is because your answer should fit into the original domain. All right. So remember our domain was 0 to 2 pi. And I was like, oh, but my solutions aren't within that. And that's why I realized I forgot that 2 in front of the theta. So just be careful not to forget that. All right, so everything now is over 12. So 23 pi over 12. And now you can see you do fit in to this domain. So as I said earlier, we're not changing the domain, okay? We're not changing the domain from 0 to 4 pi. We're just using that to find all the solutions, and we're finding the solutions for 2 theta, and then we find the solutions for theta by dividing through by that 2. All right, let's do another example. Oh, no space for another example. Let me just do maybe one on the side here. I'll do it in red. Okay, so let's do sine 3 theta. So we've got a different coefficient of theta now. So d sine 3 theta equals -1 on root 2. Okay, so our domain, remember, was 0 to 2 pi. Doesn't change. Okay, we're just adapting it to find our solutions. So we multiply this by whatever the coefficient is, so 3 times 3. So we're going from 0 times 3 is 0, that's why I already had the 0 in, and 2 pi times 3 is 6 pi. So effectively, we're now going around the circle 3 times. Okay, every time we go around the circle, we're having 2 solutions. So you should know that if you're going around 3 times, you're going to have 6 solutions. If you go around 2 times, you're going to have 4 solutions. All right, what was the other thing I was doing? Okay, so I know theta is equal to our general solution. So 1 on root 2 is pi on 4. But we do want negative, okay? So when we're doing the unit circle, I do only want to look at solutions when sign is negative. So we're going to be doing just like the previous question, because it was another sign, we're only doing the 3rd and the 4th quadrant. All right, so our first solution, now we're doing 3 theta. All right, so 3 theta, or 3 times theta. Okay, so our first solution is going to be at pi plus pi on 4. Our second solution is going to be at 2 pi minus pi on 4. Okay, we've done 1 full rotation of the circle. Let's go around again. So then we're at 3 pi, so 3 pi plus pi on 4. And then we're going back to 4 pi, so 4 pi minus pi on 4. And then we'll go around again. So it's not written here, but that is 5 pi. So 5 pi plus pi on 4. And then we're at 6 pi. So 6 pi minus pi on 4. All right, so let's just tidy this up. So we're going to have 5 pi on 4. 7 pi on 4, 13 pi on 4, or 15 pi on 4, 21 pi on 4. I didn't say that with much confidence, did I? And then 23 pi on 4. Pi. Okay, so this time we've got to get rid of the 3, so we're dividing everything by 3, so that's the same as multiplying by 1/3. So our denominators are now changing to 4 times 3, which is 12. So we're going to go from 5 pi on 12, 7 pi on 12, 13 pi on 12, 15 pi on 12, 21 pi on 12, and 23 pi on 12. And as I was doing that, I could see that some of them could be simplified. So 15 pi on 12 and 21 pi on 12 can be simplified. All right, I'm going to leave them all as 12, but 15 pi on 12, the highest common factor is 3, so that would become 5 pi on 4, and 21 pi on 3 would become 7 pi on 4. Okay, let's move on to question 8. So question 8 is quite similar, just bringing together the previous 2 questions. So first of all, rearrange. So let's just look at 8a. And look at our domain. So we're going from 0 to 2 pi. 2 cos 3x plus root 3 equals 0. All right, so let's just rearrange it. So we're going to have cos 3x. All right, so the root 3 is going to come over as negative root 3 and then divide by 2. All right, so let's have a look at our general solution. So I always like to keep it over here. Now that's not going to be our necessarily our actual solution because we've got the negative there, but let's just go to root 3 on 2. Scrolling back up to my not my unit circle, my table, root 3 on 2 cos, so pi on 6. And we want it to be negative. So let's draw our unit circle. Whoa, terrible unit circle. All right, so ASTC. Just going to change colors. So cos is negative in your second quadrant and your third quadrant. So we're going from 0 to 2 pi, so we do need to actually change that just to find our solutions. 2 pi. Okay, so we're going from 0 to 2 pi. Just going to write this here, 0, 2 pi is our domain, but when we're looking for solutions, because we're multiplying it by 3, so multiply both by 3, so we're going from 0 to 6 pi. Okay, so remember we're not changing the domain. The domain still stays 0 to 2 pi. We're just doing this so we know how many solutions we have, or how many times to go around the unit circle. All right, so the first time cos is negative is in the second quadrant. Okay, so we're going to have 3x equals, so pi minus pi on 6. All right, so remember we should have 6 solutions. Our second one is in the third quadrant, so it's going to be pi plus pi on 6. Then we go around the circle again, and then we're at 3 pi. So it's going to be 3 pi minus pi on 6, and then 3 pi plus pi on 6. Now, if you want to, you can, I was just thinking then, right, instead of writing 3 pi, you could write 18 pi on 6. You can write it straight away as an improper fraction if you like. There's no need to, if you can easily do it in your head. So you'll notice when I first started doing this, I did do the working, but now I just quickly do it in my head. So 3x, all right, so we have 5 pi on 6, 7 pi on 6. Oh, what's that? 18 minus 17 pi on 6. 19 pi on 6. And then 29 pi on 6. And then 31 pi on 6. Now, that's quite time consuming. So if you wanted to go ahead and just write them over 18, because we've got the 3x and we want to get x on its own. So that denominator now changes to 18. So you could do that in one go if you wanted to. Just be careful not to make any errors. And usually errors come when you're copying. All right, let's just quickly do this. My hands are freezing. Anyway, and I'm just going to see if any can be simplified. I think they're all prime numbers actually. Okay, so nothing can be simplified there. Okay, we've only got space to do one more, and I feel like we've done enough that you can do the other questions anyway. So remember, you can check your solutions in the textbook. Okay, so let me just choose one. Let's do F. So we've got 4 cos 3x equals negative 2 root 3. I nearly wrote negative 2 on root 3. All right, so we're going to divide both sides by 4. All right, so that's going to be negative 2 root 3 on 4. So that's going to give us negative root 3 on 2. All right, so our angle, root 3 on 2, I think it's pi on 6. I'm starting to learn them. pi on 6. Okay. We just did that, didn't we? Oh gosh. Oh, I'm just wondering whether, actually, let's not do this one because it now works out to be exactly like the one we just did. All right, let's do a different one. Didn't realize that. Where did everything go? Where am I? There we go. All right. Now, Word doesn't like me writing on here. I think it uses too much memory. So sometimes it glitches. Okay, so let's not do F. So we're going to get pretty much the same answer as the previous one. All right, so it did glitch. I just had to restart it again. Or is it playing up again? Okay. No, it's not. All good. Okay, so we just did a cos. Let's maybe do sine. Let's do D. So we've got... all right, let's try again. Sorry, it did just shut down again on me. So D, there we go. This is the last question we're going to do. So let's hope it all works out. Okay, so let's get sine on its own. So sine 3x. So the 5 comes over as positive 5 divided by 10 is going to give you a half. All right, so going up here, now I think it's going to be pi on 6 from memory. Let's just double check. Good. All right, so pi on 6, and it's going to be positive. So our first solution, 3x, is going to be pi on 6. Now, as I said before, if you want to change your denominator straight away, because I know I'm going to have to eventually divide by 3, you could write pi on 18. Okay, so I'm going to do both at the same time just to show you how to do it. Now, our domain is 0 to 2 pi, so because I just enlarged it, because I got 3x, I'm going all the way to 6 pi, so I kind of covered that in the previous one. Okay, and sine is positive, so we want first quadrant and second quadrant. Okay, so our first solution is going to be 0 plus pi on 6, which I've already got, then pi minus pi on 6. Now, if you want to write it down here, you could write pi minus pi on 18. 17 pi on 18. Actually, sorry, it's not 17 pi on 18. What am I doing? So, it's going to be 5 pi on 6, so 5 pi on 18. Okay, so then our next solution, we go to 2 pi, so 2 pi plus pi on 6. So that's going to be, oh gosh, what am I doing? 12, 13 pi on 6, but when we divide through by 3, it's going to be 18. All right, then our next one, we've got 3 pi minus pi on 6. Okay, so that's 18, 17 pi on 18. And then we've got 4 pi plus pi on 6. Okay, so 6, 24, 25 pi on 18. And then our last solution is going to be 5 pi minus pi on 6. So 30, 29 pi on 18. All right, so I was just quickly double checking my answers. All is well. I would strongly encourage you to do more of these. The more practice, the better. Okay, if you're still struggling, please let me know, because I haven't done many questions, but you would have done these last year, but it is quite difficult to get your head around, but once you've got your head around it, you should be okay. All right, bye.